Let's start from the main Plastic view. The main Plastic view is the Branch Explorer. This is the view where you can check at any time all the status of your project. In this view, you can see the branches and these blue bubbles that we call changesets. That means that there are the different snapshots of your project at any time. Every time you perform a commit or a check-in, you commit something to your repository, a new blue bubble will be created, and you will be able to see both of them in this Branch Explorer view. You can see here the main branch, that is the default branch that is created in your repository. If you have been working with other version control systems, you maybe call it trunk or master. In Plastic, we just call it main. And you can see here also some task branches that I've created before. There is also interesting to check that there are some green bubbles right there. These green bubbles are labels. In Plastic, we recommend to create labels depending on your workflow. For instance, when you consider that it's a stable point, when you just want to deliver a release or whatever in your workflow makes sense, you can just create a label in a changeset. And you can also see here some different types of links. Okay, this green link is a merge link. It's created after a merge operation. Then we will review in detail how a merge operation is performed, but by now just remember that it's a merge link. You can see here other type of links like this gray one. It means the relationship between the changesets. For instance, this is a changeset, say A, and the parent of this changeset is this one. You can see that one changeset can have different childs, but only a changeset has only one parent. Okay, let's continue. After reviewing this Branch Explorer, let's continue with the how to perform a commit in Plastic. How do you, after you are modifying your code, how do you perform a check-in? Okay, let's review it. In Plastic, depending on your workflow, there are two kinds of ways of work. I mean, the most classical one, if you have been working with other version control systems, is going to the items view, where you can see all the files of your project, and you can run a checkout operation. After checkout operation, you are saying, hey, I'm going to modify this file. Okay, then after checking out the file, I'm opening the notepad, and I'm going to perform a change in the file. Okay, I save the change, and we can see that the status in this item view has changed from control to checked out. Okay, so now if I want to commit this change to the repository, we just need to go to the pending changes view, where we can see all the pending changes to commit in our local workspace. In this case, I've only modified this file, the programs.cs, so I'm going to commit this change. I can create a comment, and I run the check-in operation. Okay, if we go to the Branch Explorer, we can see that a new bubble has been created. It's interesting also to review that there is like a house symbol. That means that our workspace is updated to this specific changeset. Before it was updated to this changeset, and after perform this commit, it has been moved to the last changeset of the branch. Okay. In addition to this checkout, edit, check-in workflow, in Plastic, you can just directly modify the files in your workspace without checking out or saying Plastic that you are doing anything specifically. So we call it the transparent SCM workflow. I'm going to show you how it works. If you open a file in the, notice that I'm opening a file from the Windows Explorer view, not from the Plastic GUI or something like that. I'm just directly modifying a file in my workspace. Okay, let's add a new comment. Change to transparent SCM. Okay. If we go to the pending changes view, we can see that Plastic also noticed that we have modified the file. So it means that we don't need to check out or specifically say Plastic that you are going to edit a specific file. So I'm going to commit change to. Okay, and we can see that a new bubble, a new changeset has been created in our main branch. Okay, in addition to this change operation, we can see that Plastic is able to track all the different kinds of possibilities. For instance, if I move this file to a different folder and if I also delete a file or whatever we do out of Plastic control, Plastic is also noticing the changes. We can see here that in the pending changes view, the different types of changes are in move, delete, change, audit. So you can see very easy all the different types of changes. Okay, here in addition to the checking button, you also have the undo changes button that it's very interesting in other situations when you want to undo your changes. So let's for instance undo these two changes. If I check OK, I'm going to undo those changes, and I say OK. So now I don't have any change in my pending changes view because I've undone the changes. This transparent SCM feature is very interesting because if you are using any IDE or any tool that we don't have a specific plugin for it, you can just work with it and Plastic will notice all your changes. For instance, if you are working in NetBeans that we don't have a specific plugin for it, you can just work with it and Plastic will notice all your changes in your workspace. Okay, let's continue. And now I would like to show you how to create a branch in Plastic and how to run the merge operation. Okay, in Plastic, it's very easy to create a branch. You just need to right-click the changeset from you want to create the branch, and in this menu there is an option that is create branch from this changeset. Okay, I'm going to create the tasks 21, and you can see here you can create a branch from a label, from a changeset, or from the last changeset of your parent branch. Also, I'm selected that I would like to switch my workspace to this new branch. Okay, we can see that a new branch has been created in our branch explorer. So let's perform a commit in this new branch. For instance, I'm going to modify the program. Okay, let's perform some changes on the code. Okay, I go to the pending changes view. I'm going to commit in the task branch. And if I go to the branch explorer, you can see that a new bubble has been created in the task branch. So now imagine that I would like to merge, to integrate this branch into the main branch. How can we do it? There are two steps, and it's very easy. You just need, first of all, you have to switch your workspace to the destination changeset of the merge. So let's do it. Okay, and then the second step is just right-click the source side of the merge and select the option merge from this changeset. I select this option, and now a new tab appears with the conflicts. In that case, there is only one file involved for them in the merge. There is no manual conflicts. Everything is automatic. So if I click on process all merges, the the operation is automatically performed. So if I now go to the pending changes view, we can see that there is a pending change item plus a merge link that it has been created in this merge operation. So now I'm going to commit the merge. Okay, so now we can see that a new green link has been created. That means that this task branch has been integrated, merged into the main branch. But let's review a more complex merge scenario. I would like to show you the power of the plastic merge system and how it's able to handle more difficult situations, more difficult scenarios you might have in your workflow. So let's imagine now this scenario. I'm going to create a new task branch. Let's call it task 22. And in this task branch, I'm going to perform two changes. I'm going to move the program file, cut and paste, for instance, in CM the runner example. Okay, this is my current directory. I need to move to a different one. CM runner. Okay, let's cut and paste. Okay, I've moved to the CM runner, and in addition to this move operation, I'm going to perform also an edit operation. Okay, so I'm going to edit, for instance, this line, not print CM version. Okay, if I go to the pending changes view, we will have two pending items to commit: the change operation plus the move operation, the two operations I just performed. So I'm going to commit move plus change operations. Okay, if I go to the task branch, a new bubble has been created, a new change set, in this case in the task 22 branch. Now imagine that another developer is working in a different task branch, let's say task 23, and in that case this developer moves the same file but to a different location, not the same as the first developer, but to a different location. For instance, he's moving to the root of the workspace, the file. And also, in addition to the move, he's also editing the file in the same place as the first developer. You can see that I'm trying to force a conflict that has some move operation involved and also some change operation, so it's kind of complex to check how Plastic can handle this kind of scenarios. Okay, so okay, let's check. Okay, I've run the commit, and we have two task branches run by two different developers. Now let's integrate these two branches into the main branch, and let's check how Plastic handles this situation. Okay, I'm going to switch the workspace to the main branch, and now I'm going to merge this task branch. Okay, we have two items to process, the move and the change operation. It will be automatic because I haven't performed any other changes in my main branch. So let's process the changes. and after that let's commit the changes plus the merge link from developer 1. And now let's imagine that the second developer also wants to integrate his task branch into the main branch. Okay, that's interesting. Now in that case, Plastic detects two conflicts. There is a conflict in a folder conflict plus a file conflict. In that case, we have a divergent move conflict. Plastic is able to detect the type of conflict we have, and is able to offer a resolution method for the user. If we click in the resolution method, the user can decide what can want to do. So he can just keep the move done on source or keep the move done on destination. The user is able to decide what he prefers. In that case, I prefer to keep the move done on source. Okay? Done. So we have solved the conflict in the folder, the divergent move conflict. But in addition to that, we have a different conflict. This is a file conflict. We have modified both developers the same file. So let's process this merge. Okay. It's interesting to note that this is not an automatic merge because the two developers have modified the same file in the same line. So we need manually to decide, we need manually to solve this conflict. So in that case, this is our text merge tool, and we need to decide what we prefer. In that case, I prefer to keep the source content of the file. I'm going to add also a comment because I can also modify the file, not necessarily only to select source or destination or base, but also we can add more information. Okay, so I select save and exit, and I finished all the conflicts. There are no more conflicts in this merge involved. I've solved the divergent move in the folder, and also I've solved the conflict in the file. So if I go to the pending changes view, the same as before, I can commit the changes. Commit the changes after solving the merge. I click on check-in, and a new bubble and a new merge link has been created. Okay, this is just an example or some complex merge operation in our web page. It's called Merge Machine. We have a page where there are many kind of conflicts. You can check in detail, merge types, stable twins, cycle, divergent moves, and everything. And you can check how Plastic can handle this kind of conflicts, and you can compare with other tools, and you can check that our merge tool is one of the most powerful out there because we can handle all the conflicts. Okay, so just to finish this webinar, I would like to show you a new feature that we have just released. Actually, it's a new user interface we have just released. We have presented in the Game Developers Conference just a few days ago, and I would like you to check it and take a look. It's called Gluon. This is a user interface that we have developed specifically for artists or not very technical people that works in your groups. It's very simple to use user interface, so it's very recommendable for artists or people that don't want to learn all the Plastic features. They just want to start working on Plastic and don't worry about merge, don't worry about branches, just start and work. I will show you the main views of this user interface. You can see here the items view that is pretty similar from the normal user interface. And if you click on configure, you can select the specific content of the repo that you would like to download to your local workspace. So it's not necessary to get all the content from the repo, but just the files that you are going to work on. So for instance, if the artists are only going to work on this folder, CM Runner example, so they select to get this folder, not the other files or other folders of the repo. So after clicking apply, this folder has been updated to my workspace, but not the rest of the folders. In addition to the Branch Explorer, there is a check-in changes view that is the same as the pending changes view of the normal Plastic GUI, and a changeset view where the users can check the changesets of the repo. You can see that there is no merge, there is no branches, there is no extended information. So this way the artists can start working with Plastic and they don't need to worry about more complex operations, more complex stuff that is not necessary for their workflows. Okay, so that's the main Plastic cycle. That's how Plastic works. The basics. So now it's your turn. If you have any questions, if you have anything to comment, please raise your hand in the meeting, and we can check in detail something you would like or some questions you have. It's your turn. Not sure if you are if you have any questions in the webinar. There is a button that it's raise hand, so please use it, because it seems that anybody is having any question. Any question? No, it seems that there are no questions. I'm not able to. Okay, there is a question. If you are sharing 3D models such as binary files from Maya, how does Plastic handle the merge? Okay, that's interesting question. We have been releasing in the last months very powerful merge tools. Not sure if you know about semantic merge, and also we are releasing a Unity specific tool for merging Unity files. So we are very focused on the merge side of the version control. So we try to handle as much scenarios as possible, as much files as possible. So this way the user don't need to manually perform the resolution of the conflict. So we try always to improve our merge system. So if you have some specific kind of files or some specific projects, we can check it. Maybe we can discuss in this kind of files how can we handle them. Okay. Not sure if there are more questions. Nathan or other more people in the meeting. Of course, you can reach us in our public forum, or you can just email us to support@plastic.com. So at any time you have any issue or any question, you can reach us right there. Okay. Okay. So if there are no more questions, I just want to say thank you for coming, and you are very welcome. And I hope you enjoy your experience with Plastic, and all your feedback is very welcome. Okay, bye bye. Thank you very much for your time.